Namaskar. This is Engineer Suraj Singh speaking from Bharat, India. On 21 early morning, addressing all friends around globe regarding talk that is as usual civil field engineering, designs, construction, methods, contracts, AnnexSL, organizations, communications, coordinations, quantity, quality, why behind concrete, quality and other qualities, and talk number 305. Yesterday on 26th March 2021, I talked at length, but I apologize for technical problem that was associated with that video in which by mistake sound was missing. Sound was missing, and that is unfortunate. And I tried to get it set, and I have to repeat approximately yesterday's talk in this talk. I covered many aspects of buildings, quality, house building, non-plant buildings, and many other issues which you can see in these files as role of site engineer, then non-plant buildings, and then house building. I covered many issues, but it happened unfortunately that I could not even say role of site engineer, for example. I tried to explain this, and also I tried to explain non-plant buildings and house building, all these. Time, cost, risks, reliability, analysis, synthesis, thinking, contemplation, application. These few points for some application. You have to think a lot. It's not simply that by closing eyes, by closing mind, we can decide something to apply. It doesn't happen. We cannot do that. We have to apply something that's called application, which is based on some contemplation, means deep thinking. You can say contemplation means a grid of thinking, a sphere of thinking, thinking's volume, thinking's exponents, which summing up or netting in leads to state of contemplation. You may not define it in your language, but some templates are created in our minds for something unknown templates with some format and concentration of all those templates in one Excel, one collimation, that can be called, deep thinking and contemplation, and thinking exponent as well, which become results of certain work of analysis, many activities of analysis for respective problems and each problems, and then after getting solutions, we sum up them to in their right places, and which resulting system network is called synthesis. And all these should be reliable. Reliability factor must be there. 100%, 90%, 80%, 70%, to whatever extent it is feasible, it is possible, that must be considered. What value of reliability we are getting by these considerations, which means whatever we have done or whatever we are going to do, it must be safe from every aspect of technical and non-technical consideration. Whatever work we do, it must be safe, it must be sound, it must be, workable successfully, and also it must be serviceable. Whatever intended service it has to give, it must give, or what we expect it to give according to our calculations must give service. whatever service it is, structures give service, buildings give service, all these give service. Then also we can say it must be durable, means for whatever length of time, whatever longevity, we design something, we consider something that must functionally work for that period, and that's called durability. So if you say reliability equal to safety plus serviceability plus durability, and added on to all them are risks cover. Whatever we consider could be risk factors, those must be covered. Those must be contained, means risks should be mitigated to a maximum extent. Whatever risk we expected of those, all these, all these factors I narrated, those risks must be to whatever possible extent be contained in, and then risks should go away, and useful, or you can say a kind of equivalent opportunity, must be in. And it then depends, all these factors, jointly dictate and value in cost factors, short-term cost factors as well as long-term cost factors, both current cost factors and life cycle cost factors, or life of that project cost factors, light of that structure cost factor, which is very important point, significant point for consideration. Maybe today you are spending less on that by your estimation, but in future, working of that function of that in life, maybe 100 years, 50 years, 20 years, 30 years, it may be expensive. So it's not that only today cost you should consider cost in totality as well. And time. Time is most important, because working time of that, production time of that, project time of that, and value of that time, and also you can say in future that durability, which I said, life of that work which you do, an operational unit we produce, it makes value, because if you increase time of that by doing all this, by doing all I said, all these factors keeping appraised to calculate, you may increase time of that work, even if some retrofitting is required. This means this will impact cost in future, of course, and risk will be mitigated. This plant may work more than 30 years, probably 40 years, 50 years, depending on revision of technology or update on technology. So time is that level factor, and then you can say which method we use, that depends on that. Which method was best to depend on that, because it is construction. Method statements are very important. Means method should be known. Well, it's known verbatimly, or it's known in verbatim, or it's known in written position or document. It must be known how to do something in construction. Plus, you can say construction is by convention or by design or by, you can say, calculation or by establishing certain procedures and systems. And that's what is very important. And that all depends on designs, what designs we got, we did. Not only structural design, I'm talking all designs. Designs in totality. Everything is totality, like total method statement, total design, total construction. And ultimately, all these come under super title, that's quality. Quality of design, quality of construction, quality of method statement, quality of time, quality of cost, quality of risk, quality of reliability, quality of analysis, quality of synthesis, quality of thinking, quality of contemplation, quality of application, from starting and quality of application, the end result of that, quality application, quality contemplation, and all going up to quality, that is quality plus quality totality. That's where we have to see. So quality definitions you have to define yourself. Don't depend on what institutions claim, that is ordinary claim, that is claim within certain bounds, certain limits, but we have our own limits. If for as an individual I invest something in my own, even I invest time, I invest efforts, I do some research work, I do something, that's my quality. If I abide by all the systems, and also on top of that, I take interest in my own development, in my own additional or augmented value of quality, power of quality. Nobody can stop that because it is super quality, you can say, or future quality, because quality that's defined 5-6 decades back do not stand today. It doesn't stand today at all, because many technologies have come in and those quality have become obsolete, are gone to history, and current quality shall become history after a few years, a few decades, and new qualities will come. So it depends upon what design factors you take, what material we consider, construction technique or method statements. We call generally methodologies. So I don't call it methodologies, I call method system. It's method theory, or you can say procedure. There's nothing technology because you devise yourself. Yes, it's just a procedure how to do it. Yes, if there's a technology involvement, you are call it method technology, depending on material technology or process technology, or you can say whatever technology access, but method statement is just a procedure, it's a format. It's a format to communicate to others what it should be done, how we want to do it, and that should be agreed by everybody who does it, who is involved on that. And that's the important point, which we have to see. Method statement is just a medium. It's like a journal. It's like a report. It's like a proposal. It's like an agreement. And we have to do this. It doesn't mean that you can't deviate from that, depending on customized requirement or current requirement or site requirement. But as far as result remains same, durability and safety, and you can say serviceability remains same. There's no adverse impact on quality. There's no adverse impact on time. There's no risk factor involved. Solution is involved. So reliability, risk, cost, time are considered. Then we can say it's a good synthesis and synthetical answer based on contemporary thinking, based on contemplation, and application is answer. Application is ultimate engineering product. Whatever product is, that is one application of that engineering, and engineering application, new and new application, conventional applications, old applications, application that have been obsolete, all were applications sometime. Now this new application, new product will come. So application is ultimately an answer which we must try to understand. In this regard, I yesterday talked of site engineers or project workers or role of site engineers, which is a very important part of engineering. We cannot go without that, because ultimately site guys who work on projects, those are very important people. Maybe they are not given value. That is a different point. The role of site engineer is very much important. We have to give value to that. We have to take that into consideration. After all, what is their role? We know their role, you know everybody's role, but what is site engineer's role? There has been some misunderstanding. Site engineer is actually very responsible position in engineering world, because ultimately site engineer, actually you call them construction engineer, or you call them project engineers, or you may call them project leaders, because they ultimately, site engineer ultimately lead projects until projects are projects. I mean to say, a state of whatever unit we are going to consider is called project. Until it is brought into operation or use, it's called project. Though you may call project forever, but project means some certain activity or sum of activity or sum of scheme that starts on one day, which is called date of commencement, and same scheme when it ends or is completed, that's called date of completion, or you can say date of occupation. When you occupy that, on that day, project goes away. It's no more project, but or it is, you can say, whatever infrastructural unit that has been commissioned or used, and it comes into operational unit status, and it's called operational unit. Project status goes away. So date of commencement to date of handover or date of occupation, this gap is called project duration. We started somewhere, as we said earlier. What we said earlier, project starts when feasibility starts. When we start feasibility, okay, this is feasible, we do it now. That day, it can be said that this is number one day or square one of project, not of construction project. I'm saying project, and up to date of occupation called project duration, total project duration, and which project duration may contain many projects, sub-projects like, feasibility report, as I said, which includes a lot. It includes, lot surveys, superficial surveys, air surveys, all some of the surveys, plus budget estimates, and also feed document construction, the production. Feed means FEED, that stands for front end engineering design. FED, front end engineering design, means you are on front of other front, not this front construction front, other front of pre-contemplation design, and that is when you have to establish facts, what way you have to design, what is the scope of the design, which formula or group of formula or group of sub-leads would be used or may be expected to be included in that design. And then you can say, after compiling, after composing feed, we have to start executive design, or you can say working design, or you can say real design, or proposed design, which is very lengthy process, so very lengthy process of whole gross design, you can say, or you can say key design, and then sub-key design and working solutions. So there's a lot of length of that, you say, and then after you can say other project comes in, and that is contracting, means how to compile project documents or tender or bid documents, and then how to convert them after contract is decided to contract documents and execution or prosecution of those works, and then contractor or ourselves complete that work and